Всем привет, в эфире канал FunTalk. В прошлом выпуске у нас был System Design Mock. Мы разбирали, как дизайнить биржу. Те, кто не смотрели этот выпуск, идите обязательно посмотрите, задайте свои вопросы, что у нас получилось по этому моку, что не получилось, какие хотите еще разборы посмотреть на нашем канале. Также ставьте лайк и подписывайтесь. В этом выпуске мы будем разбирать как это, white paper, да, его все называют. В этом выпуске мы будем разбирать white paper от Гугла, сервис, который называется Google Chubby, и рассказывать о нем будет Катя. Катя, привет.
Да, всем привет. Сегодня мы поговорим и узнаем немного о Chubby. Выпуск будет на английском языке, поэтому подготовьтесь морально, вот. И вести, в общем, так как весь пейпер на английском, говорить мы о нем тоже будем на английском. Okay, let's probably switch in this case. So for our agenda today, we have several topics to cover. Firstly, let's start with some introduction about what is Chubby, what is the system it's used for. Then we will talk about design, like basically the whole parts that we have in Chubby. Then we will talk about some issues and mechanisms for scaling that Chubby has. And also, one of the most interesting parts probably, how exactly it works in Google in experience. But we notified that all this data is from 2006, so it's quite old. But at the same time, it's still interesting to see what there was design and how they tried to actually implement it and how it worked. Okay, so what is a Chubby? Chubby is a log service, and it's intended to use with loosely coupled distributed systems, consisting with a large number of machines. We can say it's kind of very large because it's 10K. It's not like super large as we can say, but still not small amount. All these machines are connected by a high-speed network, and we use Chubby with a special type of log. It's called coarse-grained log. It's a bit hard to translate in Russian, but basically it means the difference in this log that is used for more long-term logs. For example, for days and hours, and not for very fast, like seconds or minutes. And also, the Chubby log service provides a very reliable and very low volume storage. So it's basically like in terms of bytes, but not a very large amount. Also, Chubby provides an interface that's similar for any file system, any Unix file system, with advisory logs. Advisory logs is a logs that kind of advise to use, but but clients can skip it. That's why it's called advisory. And it is allowed for this system to do any file reads and writes, but you can't kind of change the file in the middle. You can't do the seek operation in Unix term. Also, Chubby provides a notification mechanism, any like file notification, everything. We have a special mechanism to receive an event notification. Mostly the Chubby built for availability and reliability, but it doesn't work with a high performance and high throughput. Especially it is emphasized with the decision of coarse-grained locking. That is, as I mentioned, is for a longer period of time. Also, Chubby uses asynchronous consensus that's called Paxos. I'm not sure if I ever covered it, but it's quite a very long topic. But basically, it's a protocol that helps us to resolve the problem of consensus. In this distributed system, it's a very common problem about like when you have like a set of nodes and you need to elect a master, how exactly you do it? Like, should they vote? Should we use a log service? Should we do some other decision? And the Paxos library and Paxos mechanism is a different paper that we can actually also can look through that helps to resolve this consensus problem. Okay, so let's go to the design. Any kind of small question before we start?
I have a question about intro. So we are on a system design channel, and we need to talk about system design. And when I was reading this paper, as I understand, it is used in different Google's products like Bigtable and some others. But generally speaking, for which, like, where should we use such kind of service, locking service, when we are designing system? When imagine we are on the interview and we need to design some system. Where usually do we put this kind of system on the diagram?
So basically, it will be a client library that you will use in order to connect to Chubby, and this will be used as a master election algorithm. So, for example, if you have a distributed system, like you have a couple of servers, one of which should be a master, like a main cell, in order to resolve for yourself this problem, like how to elect a master, you can use Chubby as a service. It's very simple, and I will dive a bit more details why exactly they use a locket mechanism. But one of the advantage is actually to have like simple way to use Chubby. So you don't need to choose your internal application code. You just need to add client and basically use Chubby as a service in order to resolve master election problem.
Okay, thank you. So we were talking about Raft, and Raft is also similar algorithm to Paxos. So, but as I understand, Raft is an algorithm, and basically this is a library. But Google Chubby is a service. So it's service which implements the algorithm Paxos. So to run this service, we need to. It's basically already a system which we can design, and now we're going to system design this to do the system design for this service.
Yes, exactly. So basically, Google thought that it's probably hard to implement like Paxos or Raft library every time then you face with this problem, and you can use like lock as a service, which is very convenient. And that is why they basically propose this solution. And in this case, like they have these two choices: should we like implement a lock servers, or should we use client Paxos library? And there were fair advantages to use Paxos library, but the main advantage of a lock server was that you actually it is easier to adopt. It is more familiar to our programmers, and you don't introduce additional dependencies inside the code. Of course, we introduced system design dependency, but overall it was a bit more loosely coupled because you have additional service to use. So in 2006, they sit and thought about it, and okay, we will do our own lock mechanism. And they made one of the key decisions. They decided to use the lock servers, and they also want to have a possibility to serve some small files. It is very convenient to have small files here because it will help to store some information about, for example, who is the primary, like additional information about mastership and all this stuff. Let me check if I covered everything that I wanted for the slide. So yes, they decided to use locking mechanism. And what were decisions that they decided to do? They wanted to make the service quite secure, so all the files in Chubby are covered with access control. They added consistent locking mechanics in order to developers to use log server mechanism. It was also simpler for developers in Google. It was more familiar for some reason. And it also, they calculated that it will be around thousands of clients per Chubby file, per Chubby cell. And that is why they also wanted to have event notification mechanism, and also they will provide only coarse-grained logs, which is long duration logs. Because in this case, if we don't do it, the master cell just won't take the load of 1,000 clients. So once they set up these main key decisions, they build a structure. What do we have here? So the main components is a client. Client is basically some application, like any applications that have a Chubby lib. A Chubby lib, so it's basically like C++, Java lib, whatever it is. And it basically have some API that helps to connect to some Chubby cell. Chubby cell is usually a cell that has like 5 replicas of Chubby. One of them is a master, and others are not masters, just replicas. I'm not sure how they called. So all of them are designed to serve like any clients with a Chubby lib. And what they do, like for example, how the life of the request going on, what is the address of a master. They do a DNS resolution, which is very similar to any DNS resolution name. So they go to the DNS server and ask, hello, I have this name, could you please tell me like the IP address of a Chubby master? And once they have this address, they send the request to the master. If it turns out, for example, they have an old information about previous master API or like ID, another replica will send the information who is the master and like, sorry, I'm not a master anymore, please go to another cell and talk to another replica. Any questions here?
I have just not a question, but Katya, please speak not too fast for us. We have barely understand what is going on. I have a question about not master nodes, about replicas. So master is accepting all the writes and reads, and it looks like all other replicas, they are just responding with the location of the master node, and it's quite not performant. I mean that the point of the replica is just to respond at the location of the master. Did I get it right?
Not fully. Here we only see the life of the request of the resolution, but actually replicas are used in order to read data from the files. So they totally fine to serve any read request responses. So yeah, they're not only like telling, okay, please go to another master.
Mm-hmm. Okay, thank you.
Okay, there is some diagram. Let's see what happens here. So it actually talks a bit about how Paxos used inside Chubby, because Chubby uses Paxos algorithm in order to elect masters inside their replicas. For example, if we look to the diagram here, firstly, a replica that wants to be a master basically sent a request like to another replicas with a way like, please vote for me and promise not to vote for someone else for some least time. Usually it's kind of 12 or 10 seconds. During this time, like any replicas do not vote for others, and they need to acknowledge that they will do it. Once one replica receives all these answers and it has a quorum, quorum is basically, there is a formula for it, but for example, if you're talking about if we have 3 replicas, quorum if 2 replicas are voted for one master. Once we receive a quorum, we update all the replicated logs for all the replicas. Then they send information to each other about like who is the master, and after master is elected, after some time it could send another request that's called repair. It will send the same request like, okay, like I'm a master, could you please vote again as a quorum for me for next cycle of mastership. Here on the left we have kind of more detailed explanation how this works with Paxos. But basically, as an example, as we see on the right, is how it works on the practice. Questions?
I don't have specific questions about Paxos. It's just it's so complicated, even in Russian when you're reading it in Russian, but in English it's more complicated. I don't know, Kate, what do we need to know about Paxos? I see just stages. I see that it looks like in chat people saying that it looks like something democratic. I mean, do we need to know Paxos? Do we need to understand anything about it, or we just can think about it as some kind of black box with some function like this is the leader and that's it? Do we need to actually to know the stages of the Paxos election algorithm?
I think in most cases it is not required to know all of this, like how exactly it works in details, because it's pretty low level. In most cases you have it as a service, even though like right now we're discussing Chubby that's actually provided as a service and it's implementing Paxos. So it's very highly unlikely that ever in your career you will implement Paxos fully. And I think when you have this opportunity, you will open a paper and read how to do it. But basically it's a library that actually helps you to do it, so you don't need to implement it from scratch. You just need to use a library.
Okay. Thank you. We have two questions in the chat. One of them is, what do we? I mean, it's a wide question, but basically, what do we do if we have split brain? What if we have two masters in the Chubby, or it's always only one? What if we one part of the cluster elects one master and one of the part of the cluster started electing another master? Can it be like that?
So I think mostly the problem of a split brain is covered by Paxos library. So for Chubby it's the same. For example, if it happens that two replicas think they are masters, there are some failover and recovery disaster mechanisms that help the system to understand, okay, like it looks like we have two masters, probably we need to do something about it. But basically one of the master will be either turned down or it will be a re-election, because if we have splitted brain, it means that something was happening with different replicas. For example, they were not available, or some networking issue, something like that. Yeah.
Thank you. Another question from Dan in the chat, like, okay, if we can select only one master, but what if we continuously do re-elections? So we try to select one master, but we failed because, I know, for some reasons, then we try it again and we try and again. Can it be that, I mean, this Chubby service can work on how many services? A lot of services. So a lot of services. So we can how do we proceed with election? I mean, can it be the situation when we continuously trying to do elections and there will be never the end of this of these elections?
Yeah, very bad democratical state, isn't it? So just in case, right now we're talking about implementation of Chubby. Chubby uses paxos to do master elections inside Chubby. It's usually only kind of 5 replicas, some odd number, in order to make election easier. But at the same time, we can use Chubby in order to elect our masters, and this mechanism is different. We use a lock service, which is Chubby, and usually like who gained a lock, and this client will be a master, the one who secured a lock, and the mechanism is different.
Cool, thanks.
Okay, let's go next. Okay, let's talk about what the file system Chubby exports. So it basically uses very similar to Unix file system, but it is a bit simplified, which is nice. Basically, it doesn't have any symbolic or hard links. It's just a tree of files and directories separated by slashes. And we have one prefix that is common. It's called ls, but not because like lists everything, but it stands for lock service. The second part is the name of a Chubby cell. Usually it is resolved by DNS lookup because we can have a lot of Chubby servers. And the remaining part could be as long as you wish, but basically some directories and file names that you can store in Chubby. And yeah, all of these files are sealed, so basically you have some rights in order to read, write, and as far as I remember, rename. All these files called nodes. They would be permanent in Emperor. I don't think we need the details right now. And yeah, we have a metadata for each node. And with metadata we have ACLs, like we can set up who can read and who can write and who can change the name of a file. Also, we have some additional phone numbers in the metadata. It is instance number, like every time we create this node with the same name, this number is increased. Content generation number, it's every time we change the content, this number increased. Log generation number is when we try to log the node and do the modification. And the ACL generation number, like any changes of ACL will increase this ID. All of these numbers are like summed in one checksum. It is used in order to, like, for clients to understand whether some changes were done on this node. It is very useful because all the clients have caches of nodes, and by checking checksums, they can understand, okay, my cache is expired, I need to have a new cache. Also, yeah, we also can have handles. Handles allow us to receive some additional information about Unix file description, file descriptors. So if you're familiar with Unix file description, it's very similar, like additional mechanisms that we can use in Chubby. About locking. So on the first overview, we mentioned that Chubby uses advisory locks. And what we mean by that is that every Chubby files, every Chubby nodes has lock on the files. And these file locks are advisory, so it means that clients are responsible for maintaining these locks. So basically it's has different sequencer usage and delays that you can use for lock. I'm thinking whether we should go to too much details about it, but basically every client that has a node, it can lock a node, write some data, unlock, and basically do some locking stuff on every node. Okay. If we working with Chubby, we can receive different types of events, especially when we make some modifications. We can receive on our sessions that we keep to a Chubby master different events. First one is very interesting. It's called Jeopardy. It happens when a session lease is timed out, and the grace period starts. It basically means that something went wrong and there is a failover going on. So, for example, we are selecting a new master, and it means that right now we don't have an exact state, and we notify all the clients about Jeopardy event. Also, we report about that everything is all right, and our master has fallen over, and we also can send an expired event. All these events are handled by the client, so they can subscribe to different types of events when they use a client library on their application. So they can subscribe to different parts, like, for example, if the file that they interested in is modified, some nodes added, removed or modified, master file over. All these events could be used by application for different type of scenarios. For example, if there is an event that someone changed a master of application, for example, you want to report to the logs or send some metrics, for example. Okay, so before we go to the API, any questions?
Yes, I have a question about identifiers. So we on the previous slide you showed that one of the identifier it's a hash. It contains of four long numbers, and maybe we can just talk about why do we need so many identifiers? Why do we need four? Why it's not five? Why it's not two identifiers? Why we can't use just UE ID for that? Why do they need to grow? I mean, because it's I think it's important for the system design how we design identifiers. If you have some more information about it, let's talk about it.
So I'm not sure why they didn't use UID. For example, they use just incremented counters. Basically, as far as I understand from the paper, they wanted to check whether event is happened or not and keep this sequence number for each type of event that could happen with the file. And as a checksum, they basically just concatenate all these four numbers and okay, if number change, probably some change happened. So it's very simple. I'm not sure whether nothing kind of more interesting is done here. Maybe it was enough to do this simple solution. So yeah, no more insights on this part.
Okay, thank you. Next question is about events. So if we have we have just file system and files where we can have where I can get some logs, but then we also have events on each file. We can kind of subscribe and get all the notification about this file. What is the usage for that? I mean, for logs, I can imagine that, for example, if we are deleting some table in the database, for example, in a big table, it's good to have a log on this table, and then other service can check if this table already deleted or not. But what is the usage for the events? If you have some ideas why do we need that, it would be helpful.
So basically, one of the common scenarios of these files in Chubby is to store some data about the service nodes. For example, you have 5 nodes and you want to make a master election between them. You probably store the locations of these nodes and like some metadata about it. And for example, as a scenario, you added additional node, like you turn up a new server, and you put this information into the Chubby cell. So it's like started, sends the information to Chubby, it starts, and other cells will be notified that, okay, now we have like 6 of us. And it also means that probably you want to receive, you want to maybe change your master. You maybe want to kind of make some logic between them. But basically, all these files are mostly used not as a database, but as some metadata for mastership problem.
Okay.
Okay, let's go to the API. I won't go into too much details, but basically the API has one of the most important function is open and closed. It's just to create a handle over a file and close this call. And yeah, other functions about writing a content to a file, changing SEO, deleting nodes, setting or acquire the logs, and work with a sequencer. Yeah, I think that's all. Yeah, when we started, Dima asked a question, we really don't use any other instances in our Chubby cell. So we actually use, and one of the scenarios that we use it is for caching. So as we noticed, our system, like we have one master answering to a lot of clients. And in this scenario, it's very useful to use cache. And the cache is actually maintained partly on the client side. So every client, they know their information about their files. So if they use the node for master election, they have it cached. And that is why they also want to receive some notifications. And if the caching is expired, they could ask for a new cache, like for a new data. So all this cache maintained by the list mechanism. Sometimes the list could expire, so they will ask for another cache. And yeah, when the file metadata changes, we will send this event to the client, and they will update their cache. Okay.
So basically, we need Paxos and Chubby to solve the invalidation cache problem. we need a notification for that to send the events when the entry of the cache is should be invalidated.
Like one of the examples that we use is actually notifying clients about that the file has changed. Probably you want to update your cache in order to help us with the load. Yes, pretty interesting because like when I was reading this paper, I was wondering why we put too much logic to a client, because the client kind of should do the logs, should remember about caching, should use the library in a way that it's supposed to use. I would be happy to answer this question, but I'm not fairly sure why. It looks like it's not so complicated as I think. But yeah, clients actually a bit smart here, and they have some responsibilities when using Chubby. So we were talking about how exactly the clients maintain their sessions. And in this case, like let's talk about the problem when we had a master, something happened to the master, and what happened during this time. So if we looked at this diagram, we have a couple of leases that master were handling, and suddenly something changes, like the cell dies, master not responding. In this case, we go to this jeopardy state. When we wait for some grace period before any new master promotes itself. Usually it's kind of 40 or 50 seconds. It takes like almost a minute for a new master to be promoted, like to use the Paxos mechanism, to vote, to have the majority, all the stuff. It takes like less than a minute. And usually by this time, new master is promoted, and we will respond to our clients. If it is not happened, then like all the clients receive some events, like, okay, we don't have a master, like also event subscription mechanism helps us in this case for clients to understand, okay, Chubby is not available, it has no master, and then probably we need to do something depending on client. So there is a bit more details about it. In the sake of time, we won't do it. So how exactly the master, how to elect new master task? Sorry. Just a minute.
Погодите, я как раз хотел спросить, если я правильно понял по предыдущему слайду, то когда у нас вот этот Jeopardy State, и клиент говорит, дайте ко мне там кэш или дайте мне что-то.
Я не знаю, но вот это вот леопардовое состояние, я пока не понял, о чем это.
Кать, пока мы не продолжили, а предыдущий слайд можно спросить? Я просто не успел, записал это. А вот смотри, у нас, когда вот этот Grace Period и Jeopardy State, и клиент приходит и говорит, дай мне состояние файла или дай мне что-то, он просто ждет. Ты говорила про минуту, что у нас там вот этот Grace Period — это минута, и мы можем ждать минуту ответа?
Да, получается, в момент, когда у нас вот этот Jeopardy State, клиенты получают это состояние, что мы в Jeopardy State, мы ничего не можем знать, и мы не можем быть уверены о текущем состоянии дел, поэтому мы ничего тебе не ответим. Мы тебе только скажем, что вот сейчас нет мастера, поэтому что-то может разойтись, поэтому мы ничего не получаем в этот момент.
Так, понятно. То есть у нас клиенты могут висеть минуту и что-то там решать, либо отвалиться по тайм-ауту, либо нет. Я, может, пропустил этот слайд, или то, что ты говорила, а где мы можем использовать такую систему? Ну, просто как будто бы минуту ждать для клиентов в целом многих, это очень...
Не для тех задач, которые используются Chubby. Chubby действительно не high throughput. В большинстве случаев используется реально для мастер лекшена. То, что ты не изберешь мастер минуту, чаще всего ок. У тебя, скорее всего, есть твой предыдущий там мастер, который работает. Если у тебя не получается промоутнуть мастера и Chubby там не available, минуту подождешь. Как бы не считается, что эта система, она не задизайнена для того, чтобы отвечать на такие запросы быстро. Не то, чтобы часто у нас случается такой стейт, но если он случился, то минута не считается какой-то проблемой.
То есть, если у меня там, условно, например, 5 там инстансов какого-то сервиса, я могу подключить Chubby, который будет помогать мне выбирать мастера из этого сервиса и делать остальные реплики, типа read-реплики, и вот эти сервисы будут ждать, условно, от Chubby ответа, кто теперь мастер, и там синхронизировать состояние. И в целом минута не смертельна, да, если у нас мастер не упал. Все, теперь понятненько.
То есть чаще всего у тебя, вот, например, мастер, он перевыбирается, в каких-то там определенных случаях. И, обычно, когда ты перевыбираешь мастера, есть рабочий предыдущий мастер. И,
если он не умер.
Если он не умер, то это, конечно, должно выстрелить, знаешь, одновременно в 2 ноги.
А в какой момент мы решаем, что нам нужно перевыбрать мастер? Вот у нас есть мастер и 4 read-реплики, и мы вот работаем, и в какой момент Chubby решает, что, давайте перевыберем мастера?
Есть мастер-лист тайм-аут, типа time to leave. Сколько мастеров держится по дефолту, я не помню это значение, честно говоря, но оно в плане там, кажется, в районе часов. Потом мастершип может, во-первых, они могут высылать эти запросы и выбирать того же мастера, то есть без изменений достаточно долго. Но есть ли какой-то, условно, полиси по поводу, а давайте изберем нового мастера просто для фана, ну, потому что что-то это долго. Я не видела ответа на этот вопрос в доке. Ну, то есть, не уверена, есть ли тут какой-то специальный механизм для этого. Скорее всего, если какие-то изменения происходят, то Mastership может схватить другой сел. Но если, ну, типа, все хорошо, то, возможно, реплики и не переизбирают заново. Ну, то есть, они там голосуют, все голосуют за одного, и тот продолжает работать, если все работает нормально.
Спасибо. И еще тогда вопросик. А вот у нас, мы когда мастера выбрали, я же правильно понимаю, что судя по картинке, которая выше была, у нас все записи идут через мастера, и он там обновляет кэш во всех этих. А что если получается так, что наш мастер находится в далеком регионе от пользователя, и запись будет долгой? То есть нам нужно что-то как-то по-другому делать, правильно?
То, что мастер, на самом деле, вот как бы один из использований, то, что у нас может быть 90k клиентов, типа 90 тысяч на один Chubby мастер, они там все ходят читать, писать в мастеры и, ну, даже с кэшем. И как они с этим работают, они как бы... ну, здесь есть разные подходы, там, типа более оптимизирован кэш, еще меньше делают keep alive mode, это мы мало поговорили об этом типе запросов, но по сути, конечно, если типа мастер далеко, Chubby сел далеко, то в любом случае будут проблемы в плане, что запрашивать клиенту далековато будет. Но как бы поставить Chubby рядом, ну, просто не особо проблем.
Все, понял. Let's go next.
Okay, back to England. Okay.
I have a question. I have a question to start. In the chat, Kate, I saw a question about that the API that you have shown. It's quite low level. I mean that you can open file, close file. I mean read directly. So it's quite low level. It's maybe. I don't know, maybe hard, maybe not so hard to implement lock on. We do have acquire, but for example, do you have or maybe in Google there are some other libraries which can solve some can solve do you have additional libraries for the Chubby that can solve more complicated patterns? For example, take lock for some time, or maybe release after some time. Some recipes for for this API, because this API looks quite low level.
Yes, I understand your question is concern. Yes, the API was designed to be very low level and very similar to a Unix file system. Of course, like right now with Google, like take into account that this paper is pretty old. It's 2006. Since then, it's kind of a lot of things happened. So I'm even not sure that they use still Chubby in the way it is here, because it was optimized and changed over time as requirements change. But yeah, I'm pretty sure there are some libraries that abstract this for clients, so not every client write all of this on their own. But I think it's overall normal way to work with any new technology. This time you have more clients that helps you to use the tool more easily.
Thank you.
Okay.
Wait, please. And we have another question about difference between Chubby-based and Redis-based distributed locking. Where is the difference and when we should use one of them?
Oh, it's a good question. I wish I could answer. Because honestly, I didn't work with Redis-based distributed locking. So I'm not sure if you know the answer. Yeah, we'll be happy to discuss and learn about it. But yeah, sorry, I don't have an answer for you just now. Okay, let's proceed with the database. Okay. So overall, in also for Chubby, we use kind of a database with write-ahead logging and snapshotting because we need to store some additional information, and mainly it is logs, different logs that we of events that we do in a Chubby. And there were different design consideration about what database to use. So if I remember correctly, they let me open my another notes just a second. But basically, they try to use some ready DB for this one. It doesn't work for them, and they implemented additional like simple database with just key value storage with read through write-ahead logging. And this database is pretty simple. It's also used in Chubby for maintaining some of the state and logs. Also one of the ways Chubby works is it allows mirroring. Mirroring is when you send some of the files of one cell to another in order to to make a mirror, like basically additional way to get these files. So just one of the ways that Chubby could be used. It's very small section of the docs, which basically say, okay, we support mirroring. Okay, so we covered the design. Congratulations to us. We covered most of the parts of this 60 pages doc. Let's talk about some of the mechanisms that they use for scaling. They also cover it in the doc. This is the page, and this page is about that. Actually, it looks like sometimes we have over 1,000 coins, 100,000 coins per Chubby master, and it's too many events, especially since every client connects with a very long session. Most of the calls is keep alive. Keep alive is this RPC that connects from client to the Chubby master and receives a response about some events if something happened. Even though we send a keep alive with a large TL, we can still optimize it a bit with increasing release time. Also, they were talking about if we have some problems, we can optimize caching a bit. We can use protocol conversion servers in order to use some less complex protocols for Chubby, and we can also optimize time with arbitrary number of Chubby cells. For example, we can use a Chubby cell in every data center, and data center is usually not very large. Like we have a couple of thousand machines, and it's better to use local Chubby cell and not to go to another data center. So basically, turn up more Chubby cells in order to serve more clients. So kind of scale horizontally in this case. Okay, another thing that they advise to use after deployment this model is to use proxies. Proxies can help to respond and reduce the server load by handling keep alive and read requests. It can't reduce write traffic because write traffic still will go to the master. But other replicas can help to answer keep alive traffic. For example, they were talking about if a proxy handle n clients, keep alive traffic is reduced by a factor of n. So basically, if you have n replicas, you can spread the load between your replicas to answer keep alives. And they also talk about partitioning, that you can partition Chubby cell. I wouldn't say it was too much a good scale mechanism in this case. I won't be diving into too much details because one of the main important for us it was proxies and recommendation for the clients. But yeah, if you want to read some details, there is a special part in the doc about partitioning. Okay, any questions about scaling?
I don't have questions. Maybe other guys have. Do you have questions in the chat? There is a question about deploying it, how it's usually installed on some service. Maybe I don't know. Can we talk about it, or we can talk about it later in experience, or we can't talk about it?
Yeah, I'm not sure which mechanism is used with whether it's containerization or not, but yeah, take into account. Yeah, I see in the chat that it's 2006, but yeah, it's a pretty old system. I'm sure it could be possible that it uses Borg, but not sure how it was at this time because it's pretty old. Okay, talking about old, Yoda want to talk about experience. So in the paper, they provided some numbers about statistic of any Chubby cells. So for example, like we see that the average number of clients is 22K per Chubby cell. And most of the traffic of the RPC rate, if we see, it's mostly the skip lives. It's basically sessions that we receive. So most of the load for Chubby goes for sessions, and other like write and read is basically fractions of the load. So there is some analysis what we received from the stats. So they mentioned that there were 61 outages overall, and most of them were less than 30 seconds. So about the question whether we need to wait for a new master, like 30 seconds sounds not too bad. Other caused by like network maintenance, some network connectivity problems, and only one was caused by the overload. And yeah, all this overload looks like only happened when it was almost 100,000 clients for one cell. Also, they were talking about additional clients. In this case, they were talking about Java clients. Because mostly Chubby was written in C++ and provided only C++ library, but in the 2006, Java was started to be more popular, and they added additional Java clients. Basically, yeah, they said, okay, we implemented it because it's nice to use it. Also this client. Just try to remember what was called, but okay. Chubby was designed as a log service, but actually it was popular just as a name server. So to get some DNS and DNS caching. So some of the clients actually use Chubby as a DNS server in order to ease translation from DNS names to Chubby names. So it's one of the examples that on a practice, clients started to use Chubby not only as a log service, but also as a name service. And actually, we didn't go to too much details about this part, but actually the first failover mechanism that they proposed actually was not ideal, and it has some problems. Yes, they mentioned the database that they used. It was Bakerly DB. I haven't heard about it before reading this paper. So they used this on their first implementation, but then they implemented their own database, as I mentioned. So they talk about what was wrong in the failover mechanism and kind of change some steps during this mechanism in order to make it more reliable. And also they were talking about some of the clients that actually were not following all the guidelines that was given them. So, for example, some of the clients were not really caching a lot of data, and it caused additional load for Chubby. Like, how surprising if you send too much responsibilities to a client, but yeah, it was a surprise for them. So yeah, they were talking in the paper that they underestimated the lack of caching on the clients, and it actually caused some performance issues. Also, they like when they designed Chubby, they thought the Chubby is not a storage system. Of course, it has some files, but it's not for storage. And when they launch it, it looks like a lot of clients decided to use it as a database, like as an additional database. And since initially they didn't have any quota, they need to implement additional quota and set up a size limit, and it was equal to 256 kilobytes. And yeah, like some of the event mechanism that they use, it was designed not as a publish script. It was mostly about when you keep a session and receive a callback about some very important events for you. But the clients overused this mechanism in order to receive like notifications about their files, which they purely stored on a Chubby as a database system. So they mentioned some lesson learned. And first that they mention is developers rarely consider any availabilities when they build the system, especially from scratch. Usually it starts like you have one server, you don't think about availability for your servers. And for example, when they start to use Chubby, they have this assumption that Chubby will be always available, so they don't think about any case, what will we do if Chubby is unavailable. So they fail to predict any scenarios what to do in this case. And they, like a lot of clients, were failing to use API in effective way for these outages. For example, most of the clients were not really good about failover mechanism of Chubby and how to handle it in their applications. Okay. So they were talking about what could be changed in Chubby log service. So they were talking about it is possible to ignore fine-grained locking. So yeah, they can use and find a way to use coarse-grained locking in the future. Also, they were mentioning that their API choices were not ideal. It's mostly connected with calls and poison RPC calls for a long-running calls. They like overall it was not used very good by clients, and they think that they could change it in the future. They also mentioned that RPC use affects transport protocol. So they were thinking that they could change the protocols with additional TPC-based get event and RPC call. So I imagine that most of these design changes might be implemented in the future. So might be that if we look right now in a Chubby, if it is open source, I'm not sure, we can see this implemented. But yeah, when they publish this paper, they talk about this part.
Do they have any updates about it? Because it was in 26, right?
2006.
2006, right? And
yeah, honestly, I haven't checked when I was preparing this talk, but it's a good exercise to see what is the state right now. Personally, I say that a lot of services right now use Chubby, but how exactly it works under the hood right now, I'm not sure.
It is now in Jeopardy state, I think.
No, it's client is a Jeopardy state for
Yeah.
Chubby.
Yep. I have a quick question. So you show that actually, as I understand it, quite easy to misuse the API. So we like Google build Chubby for coarse-grained logs, but people use it as they want, and you can. There were attacks like we can educate people, but what I mean, how what are the how can we prohibit it? So what can we do? Is it usually like we have, I know, some overload on some log, and then we go and find this log in the file and fix it only after that, after we have already some severity issue? Is there is a way to fix it before it will go to the production?
So I think it's hard to predict everything. So for example, when they designed it, so basically what we see in the paper, it was initial design. Yeah, when they send it and actually clients start using it, it's actually in the hindsight, they see the problems in their design. So it will always happen because you can't think about like every possible scenarios, unfortunately. I would say in their case, probably they were too optimistic about internal clients. So they put too much kind of responsibilities on the clients. So they kind of expected that to be super smart. Maybe at the time they think that all internal clients will follow all these guidelines. But yeah, then they think, okay, probably we need to design our API in a way that it was not misused by clients.
Yeah, and another question. So as I see, it firstly was written in C++, then to migrate to use it from Java, there was additional service which like proxies request to Chubby. So as I understand now, it can be that in Google they have additional service which is written in a gRPC, and now we have kind of better API for the low level API that we have, and maybe we can create new the API that could be harder misuse than previous one, low level API. You know, they create API over another API. What do you think? Do they have something like that?
So I think they have some client libraries additional that are more abstract than the initial API. So yeah, I think like most of the clients, like at some point they think I probably provide some additional libraries with more abstract API, but at the same time, some services really need to work on this whole level. So not for every service the more abstraction will do good.
Okay, thank you.
Okay, so to sum up what we learned today. Chubby is log service, and it's distributed log service for coarse-grained synchronization of distributed systems. It helps to resolve distributed consensus among few replicas for fault tolerance. It consists of server-side and client-side, and client-side has caching, which is consistent. It has notifications of any updates, event mechanism, and inside is familiar to a file system interface. It is became the primary Google internal name service on a practice in 2006. So a lot of like GFS and Bigtable were using Chubby in order to elect primary from redundant replicas. Standard repository for files. The repositories for files that we use, they require ACLs, and yeah, we also have some small amount of metadata for every file. And Bigtable uses Chubby, for example, to elect a master, to allow the master to discover new servers when it connects, and to permit clients to find another master. And that's all. Yay.
Thank you, Kate. Do we have additional questions? Do we need to switch to Russian? I don't know what we're going to do.
I have one extra question. First of all, thank you, Kate, for your summary and very interesting topic. Maybe do you know what about disaster recovery in the context of the Chubby? How Google provide these events?
So we were talking about the over mechanisms, and for example, like something happened and master not available. Let's find it. Yeah, basically, this event that we're talking about is one of the ways to fail over when we have some master collection problem. Of course, it could be helpful as we see the report of events. Like they were mentioning that there are 60 different outages that happened with Chubby, and most of them were some like master was not available. But if we have some networking problem, it could be a bit harder, because if the Chubby cell is not available in the database fully, then the client should fail over to another database, another Chubby cell.
Okay, thank you. Also, maybe I missed something, but what kind of the protocol Chubby use for synchronize?
You mean for the replicas inside Chubby?
Yeah.
And they use Paxos.
Okay, thank you.
Okay, let's maybe sum up not the Chubby paper, but try to come up with some summary for regarding the system design. I mean that there are quite there are several ideas which I really like in this paper. For example, the idea to implement locking service and implement it as an API which is similar to file and folders API. It's really cool idea. I like it, but also I like that they enhance it with the events that you can subscribe kind of on the file and get all the updates. So it's for the 2006. It's quite how to say modern idea. I mean that I don't know. Did the Amazon simple S3 storage exist in 2004? Because in Amazon S3 they also have like file path, and all the abstractions are written around this file path. And here in Chubby we also have abstractions around file system. So it's an interesting idea to design some system around files. I like it.
Yeah, I think they try to keep it very low level at the same time, similar for programmers and the clients. So that is why probably they use file system as the abstraction they use for their files. And yeah, like 2006, I don't even remember which services were available.
Yeah, cool. If we don't have more questions, we can stop here. Okay, thank you very much, Kate, for the awesome presentation. It's our first episode in English, and it's a great success that we achieved. Thank you very, very much for that. And I don't know, should we switch to Russian? Для наших слушателей пишите, пожалуйста, комментарии. Хотите ли вы еще выпусков на английском языке? Это был такой супер эксперимент, и нам надо сейчас еще обсудить после выпуска, как оно прошло. Но вы пишите комментарии, пишите о том, какой классный выпуск, и обязательно подписывайтесь на канал. Все, всем спасибо. С вами был канал FunTalk. Всем пока.
Пока.